So in the previous video, I introduced you to an important concept of sequential circuits, which is storage, how to store data in a logic circuit. To accomplish that task, we looked at two different kinds of latches, and we also looked at flip-flops. Now, the drawback of latches and flip-flops is that by themselves, they only store one bit of information. Computers typically deal with larger chunks of information than just a single bit. Computers often deal with bytes, which are 8 bits, or words, which are 32 or 64 bits wide. So to be able to store that amount of information, we need to use more than just a single flip-flop to make that happen. So we have what are called registers. Registers are very important pieces of computers, and you can see from this diagram that registers are actually just multiple flip-flops strung together. So they are all connected to the same clock signal, right? And then I have a data value coming in for each bit, for each flip-flop in this particular register. I also have outputs coming for each bit or each flip-flop of this particular register. So again, we can see that these flip-flops, since they are D flip-flops, are going to operate on the rising edge of the clock cycle. That means every time the clock goes from low to high, these data values will be read into these flip-flops, and the outputs over here on the other side of the register will change. Anything that needs to read this particular register can just tap in to these outputs and perform whatever tasks it needs to accomplish the job. So we can see in this particular configuration, I have 3 D flip-flops. That means I can store 3 possible bits. If I want to construct larger registers, all I need to do is extend this to include more D flip-flops.